In the history of science, there are these huge, famous stories that we all learn about. But sometimes the people who were actually at the center of it all, well, they get left out. Today, we're digging into the real story behind one of the biggest breakthroughs ever and the incredible woman at its core. Picture this, it's 1953, and Francis Crick walks into a pub in Cambridge and makes that incredible announcement. We have found the secret of life. I mean, what a line. And that's the moment that pretty much sealed his and James Watson's place in history as the guys who cracked the code of DNA. But here's the thing. Did they really find it all on their own? That's the big question, isn't it? Because behind that famous quote lies a much more complicated, and for a long time, a much quieter story. And that story revolves around this woman, Rosalind Franklin. She was an absolutely brilliant English chemist and a true expert in a technique called X-ray crystallography. And her work wasn't just about DNA. We're talking viruses, coal, graphite. She was a scientific powerhouse. So, let's set the scene. It's 1951. Franklin is already a top-tier scientist. She gets recruited by King's College London for one very specific reason, her expertise. Her mission? To lead the charge on figuring out the structure of DNA. In fact, she was the only one there with her level of hands-on experience in this field. Okay, so what exactly is this X-ray crystallography thing she was so good at? Well, imagine you have a tiny crystal of a molecule. You basically shoot a beam of X-rays at it. The rays bounce off the atoms and scatter, creating this complex pattern. Your job is to then work backwards from that pattern to figure out the molecule's 3D structure. It's like a mix of incredibly hard science and pure artistry. Now, Franklin's time at King's was, without a doubt, scientifically groundbreaking. But it was also filled with tension and conflict, which led to this kind of mysterious nickname she was given after her death, the Dark Lady of DNA. And this right here, this gets to the heart of the problem. It all started with a massive failure in communication. The guy in charge of the lab, John Randall, he just didn't make things clear. Wilkins had been working on DNA, but he was away when Franklin was hired. She was told she'd be in charge of the project. He wasn't told that, so when he came back, he thought she was his assistant, not his peer. A total mess from day one. And to make a bad situation even worse, their personalities were like oil and water. Franklin was super direct, intense, all about the hard data. Wilkins? He was shy, kind of slow to speak, and apparently avoided eye contact. They just couldn't connect, and that professional friction, it really poisoned the well. It got so tense that it even turned into these, very nerdy inside jokes. What you're looking at is a satirical death notice for the DNA helix. Franklin and her student wrote it to poke fun at Wilkins. See, he was dead set on the idea that DNA had to be a helix, but some of her early data on one form of it wasn't quite proving it yet. It's a funny, sharp-witted example of just how strained things were in that lab. Okay, so all of this tension, all this friction, it leads us right here to the single most controversial moment in this entire story, the moment that honestly changed science forever. Working with her student, Franklin perfected her technique. She built a better camera, controlled the humidity, and she captured this. This is photo 51, and it's been called one of the most beautiful X-ray photographs ever taken. That perfect X in the middle? That wasn't just a pretty pattern. That was the smoking gun. It was undeniable proof that DNA had a helical structure. So how did Watson and Crick get their hands on this game-changing image? Well, this is where it gets messy. Maurice Wilkins, apparently out of frustration, showed photo 51 to James Watson. The key part? He did it without Franklin's knowledge or permission. It wasn't his to share. And if that wasn't enough, Watson and Crick also got their hands on a report with all of Franklin's unpublished data and calculations. They basically were handed the answer key. And this is what it all boils down to, right? The story we all hear is that Watson and Crick had this incredible flash of genius. But the truth? That genius moment was built squarely on the back of Franklin's painstaking work. Her data proved it was a helix. Her calculations showed the key dimensions. She was the one who figured out that the big phosphate backbone had to be on the outside. They didn't solve the puzzle. She gave them all the corner pieces. But here's the thing. If we only talk about DNA, we're doing a huge disservice to Rosalind Franklin's career. Because after she left King's College, she became a trailblazer in a totally different field. Just look at her career. Before she ever even got to the DNA problem, she got her PhD from Cambridge for crucial work on the structure of coal. This work actually helped make gas masks in World War II better. Then she goes to Paris and becomes this world-class expert. And then, after the whole DNA saga, she moves to Birkbeck College and starts doing groundbreaking work on viruses. Yeah, at Birkbeck, she took that same powerful technique and aimed it at viruses, like the tobacco mosaic virus you see here. Her team published some incredibly important papers, figuring out that the virus's genetic material, its RNA, was actually coiled up inside a spiral of protein. And that work had a massive, lasting impact. After Franklin passed away, her close colleague, Aaron Klug, carried on the research they had started together. And guess what? In 1982, he won the Nobel Prize for the very techniques and discoveries they had pioneered. So that brings us to the big picture, her legacy. For so long, her contributions were just ignored. But over the last few decades, there's been this huge effort to set the record straight. Here are the hard facts. Rosalind Franklin died of ovarian cancer in 1958. She was only 37 years old. Just 4 years later, the Nobel Prize for the discovery of DNA structure went to Watson, Crick, and Wilkins. And since Nobel Prizes aren't awarded after someone has died, she was never even in the running. Think about all that groundbreaking work on coal, on DNA, on viruses. You know how many Nobel Prize nominations she received in her lifetime? 0, not a single one. But history eventually finds a way to correct itself. And today, the recognition is finally pouring in. There's an official blue plaque marking her home in London. There is an entire university of medicine and science in the US that now bears her name. And look at their logo. It's Photo 51. And all across Europe, from London to Luxembourg, you'll find streets named in her honor, a permanent, public testament to her work. So Franklin's story has finally been brought out of the shadows. And that just leaves us with one last really important question to think about. How many other Rosalind Franklins are out there, hidden away in the footnotes of science history?